So question number 11, it says that there is a line that intersects a curve. So when a line intersects a curve, the points where it intersects can be found by substituting the one variable from line to in the equation of the curve. So we will have equation with one variable and we can solve it to find the value, and then we will substitute that one variable's value back in the line to find the other variable. And these two variables will give us the coordinates of these 2 points of intersection. So let's look at this, how it is done. So we have rearranged this equation. It gives us x is equal 1 minus 3y. And here, this is the equation of the curve. So we substitute the value of x here in place of x. Look how it is done. And then we rearrange this equation. It comes out to be a quadratic equation. And we factorize the quadratic equation and we get the value 2 or minus 8 over 9. So when we substitute 2 in this equation, we get the value of x to be minus 5. 2 here, minus 1 minus 6 gives you minus 5. And when we substitute minus 8 over 9 here, minus 8 over 9, it gives us 11 over 3. So we have two coordinates, one of P, one of Q. So the coordinates will be minus 5 and 2 and 11 over 3 minus 8 over 9. So we use these coordinates to find the gradient of the line PQ. We do this, y2 minus y1, x2 minus x1, and we get minus 1 over 3. This is the gradient of PQ. Now go back to the question. It says that equations of AB and CD are this. So we have the equations. We can rearrange them to find their gradients. So here we rearrange these equations. AB gives us gradient 3 and CD gives us gives us gradient minus 1 over 3. Now we comment on the AB and PQ. So we clearly see that AB gradient is 3, PQ gradient minus 1 over 3. Their product 3 multiplied minus 1 over 3 will give us minus 1. So we can say that the product is equal to minus 1. So AB is perpendicular to PQ. Secondly, CD gradient minus 1 over 3 same as PQ. So we can easily say that it is parallel to PQ. Question number 12, I will give you hints to do the first part. So find the gradient. It is asking, you have to give two reasons why it is not perpendicular bisector. This line is not perpendicular bisector of the line, another line. So one line equation is given, the other line coordinates are given. Okay. So when we have the equation, we rearrange it to find the gradient. When we have coordinates, we just use the formula to find the gradient. The product of two gradient, if it is equal to minus 1, then they are perpendicular. If they are not perpendicular to each other. So this is the first reason. Second reason is slightly difficult for you, but it's good to understand this point. So first of all, you have to think about a perpendicular bisector. What is a perpendicular bisector? It is a line that bisects another line equally into two parts. So we have one line here and one line coming like this. So this perpendicular will cut this line into two equal parts. So if we can find the middle point of the line that is being perpendicularly bisected, and that point should satisfy this equation. This concept is done here. Look. So midpoint of this easily found 2, 4. So 2, 4 should satisfy the equation 3x plus y is equal to 8. Well, 3 into 2 plus 4 doesn't give you 8. 6 plus 4 gives you 10. So that means the point 2, 4 does not satisfy on this equation. And that means it does not lie on this equation. And that is your second point, that the line does not bisect the line segment. Moving on, question number 13. Again, a challenging question, but first part is easy. You have done it so many times. A, B, and C with the variable coordinate of C. And it is given that AB is perpendicular to BC. So first find the gradient of AB, then BC, and then put them in product form equal to -1, and we will get the value of K. This is how it is done. Gradient of BB comes out 2, gradient of BC comes out K minus 3 over 4. Their product gives us value of K. It is all done here. You have done it so many times, so K comes out to be 1. In second part, you have to find the gradient of AC. Now you know this coordinate. So A and C, again using the formula, gives you gradient 4 over 7. Third one, acute angle. So acute angle is an angle that is less than 90 that AC makes with x-axis. So we have just found the gradient of AC. Gradient of AC means it is something that makes an angle with the x-axis. So when we have the gradient, we can find the angle by using tan inverse identity. So we know that gradient is perpendicular over base, rise over run, y-axis, so line like this, and x-axis line like this. Okay. So the angle between these two can be found using tan inverse. So tan inverse is always equal to perpendicular over base for a triangle. So we use this for AC, and this will be tan inverse 4 over 7. Ignore this equal sign. It is tan inverse 4 over 7. Okay. So this will give you 29 over 7. I hope everything is clear. Thank you.